The German soldiers' hands were shaking, not from fear, from cold. February 1945, Eastern Prussia. The war was lost and everyone knew it. Obergefreiter Klaus Richter was crouching in a burned-out farmhouse, holding a British submachine gun he'd taken off a dead Polish resistance fighter 3 months ago. The thing looked like a joke, like someone had raided a plumbing supply shop and decided to make a weapon out of spare parts. Stamped metal receiver, visible welds, a wire stock that looked like it came from a bicycle, magazine sticking out sideways like a tumor, no finish, no craftsmanship, just raw, ugly functionality. Hans, his corporal, had picked it up back then and nearly dropped it. This is what we're losing to. The British can't even make a proper weapon anymore, but Richter had kept it. Kept it when his issued MP40 ran dry and spare magazines were impossible to find. Kept it when ammunition got so scarce that every single bullet felt like gold. Kept it because the ugly British gun used the same 9mm rounds as his dead MP40, and he could scavenge ammunition from anywhere, from dead Germans, from dead Russians, from abandoned supply dumps. Didn't matter. 9mm was 9mm. Kept it because when his carefully maintained German weapon seized up from cold and lack of oil, the crude British gun just kept working. Now it was February 1945, and his MP40 was a rusted memory buried somewhere in Poland. But the Sten, that ugly, crude, desperate British weapon, still fired, still fed, still killed, and in a burned farmhouse waiting for Soviet forces to arrive, that was literally the only thing that mattered. Richter would never know that the weapon in his freezing hands represented one of the most successful design philosophies in military history. Would never know that over 4 million of these ugly guns had been produced. Would never know that the very crudeness he'd mocked 3 months ago was actually deliberate genius. Would never know that late in the war, his own country had tried desperately to copy this exact design when their sophisticated weapons became impossible to manufacture quickly enough. All Klaus Richter knew was that British engineering had somehow created a weapon that outlasted everything the Reich's finest gunsmiths had ever produced. And that knowledge felt like prophecy. 3 years earlier, different continent, different war, North Africa, July 1942. British Sergeant Thomas Atwood was standing in a supply tent staring at a wooden crate like it contained poisonous snakes. The stenciled letters read, Sten Gun Mk2, 30 units. He'd heard rumours about these things, heard they were replacing the Thompsons, heard they looked like something assembled in a garden shed by a drunk plumber. The rumours weren't wrong. Atwood had been carrying a Thompson submachine gun since 1940. Beautiful weapon, solid walnut stock, machined receiver. The weight felt right, felt like a weapon that belonged there. The Thompson was expensive, complicated, but it was good, really good. And now some clerk in London had decided to replace perfection with whatever was in this crate. He opened it, said a word his mother would have beaten him unconscious for saying. The Sten looked even worse in person than the rumours suggested. The metal was rough, the welds were visible and ugly, too light, way too light, like a toy. The magazine housing was welded to the side of the receiver. The side. What kind of designer puts a magazine on the side? Everyone knew magazines went underneath. That was basic. That was how firearms worked. His corporal walked over, looked in the crate, let out a low whistle. Jesus Christ almighty, we're supposed to fight Rommel with these things. Atwood picked one up. The wire stock folded against the side. The barrel was literally just a rifled tube. No finesse, no fancy machining. The whole weapon felt like an insult, like Britain was telling its soldiers they weren't worth proper equipment anymore. This is what happens when you let accountants design weapons, Atwood said. Some bastard in London decided to save a few pounds, and now we're carrying scrap metal welded together by blind men. They distributed the Stens to the squad anyway, because orders were orders. The men handled them like they were contaminated, made jokes that got progressively more bitter, called them stench guns, plumbers' nightmares, said they looked like something you'd find in a dustbin behind a factory. The Thompsons went back to supply, replaced by ugly British desperation. 2 weeks later, Atwood's squad was fighting through an Italian village, house to house fighting, room to room, the kind where you kicked in a door and either killed whatever was inside in the first 2 seconds or you died. Atwood's Sten had already jammed twice that morning. The side-mounted magazine kept catching on door frames. He hated the weapon with passion that felt religious. Then they cleared a building, 4th one that day, kicked in the door, 3 German soldiers inside, maybe 3 meters between them. No time to aim, no time to think. Atwood just pointed the Sten and squeezed. The weapon fired, just fired, no hesitation, burned through the entire 32-round magazine in maybe 4 seconds. The recoil was manageable. The weapon stayed on target. When the magazine ran dry, Atwood slapped in another one. The reload was actually faster than the Thompson. Just clicked in, and you were firing again. The engagement lasted maybe 20 seconds, felt like 20 hours. When it was over, the room was full of smoke, and the ringing in Atwood's ears was so loud he couldn't hear his corporal shouting from 2 meters away. He looked at the stain in his hands. Still ugly, still looked like junk, but it had worked perfectly. His corporal looked over. Still think it's scrap metal? Atwood didn't answer. The weapon had answered for him. And that was the pattern. Soldiers hated the Sten until they absolutely needed it. Then they understood. The crudeness wasn't a design flaw, it was the entire point. To understand why the Sten existed at all, you had to go back to May 1940. Dunkirk, the word that changed everything for Britain, the evacuation that saved the British Army by abandoning everything, that made it an army. 338,000 men pulled off those beaches between May the 26th and June 4th. Pulled off under German fire, under Luftwaffe bombing. The Royal Navy and civilian vessels performed a miracle, saved the men, but they left behind everything else. 7,000 tons of ammunition, just left on the beaches, gone. 90,000 rifles, abandoned. 2,000 artillery pieces, heavy guns, field guns, anti-tank guns, all left behind. Thousands of vehicles, tanks, left behind or destroyed. Machine guns, mortars, every piece of heavy equipment, gone. The British Army in June 1940 was an army of men without weapons. They had the soldiers safely back in Britain, but they didn't have equipment to make those soldiers into an actual fighting force. They had enough small arms to properly equip maybe 6 divisions. 6. Germany had over 150. Invasion seemed inevitable, and Britain didn't have the weapons to fight it off. Germany controlled continental Europe from Norway down to Spain. The French had surrendered, the Belgians had surrendered, the Dutch had surrendered, the British were alone, and the British Army had left most of its weapons on French beaches. Britain needed to arm millions of men immediately. Regular army, territorial forces, home guard units, civilian volunteers who might need to fight German paratroopers in their own villages. The scale of the requirement was insane. The timeline was impossible. The British small arms industry in 1940 was designed for peacetime, for quality, for rifles that required skilled craftsmen. The Lee Enfield rifle was excellent, reliable, accurate, but it took time to manufacture, required skilled workers, required precision machinery. Expanding production to meet wartime needs would take years. Years of building factories, training workers, installing machinery. Britain didn't have years, had months, maybe weeks. Submachine guns were particularly critical, essential for close quarters fighting, for urban combat, for defending cities if Germans landed. Britain's submachine gun inventory was pathetic, almost non-existent. They'd bought some Thompsons from America, wonderful weapons, but Thompsons cost $200 each. Required 70 hours of skilled machining per unit. America couldn't produce them fast enough. Britain couldn't afford them in the quantities needed, couldn't wait. needed submachine guns immediately by the hundreds of thousands. The War Office put out a specification in 1940 that must have made traditional gunsmiths physically ill. The new submachine gun had to be cheap, incredibly cheap, simple enough that workshops that had never made weapons could manufacture it, reliable under combat conditions. But everything else was secondary. Cost and production speed were the only priorities that mattered. Appearance didn't matter, refinement didn't matter, comfort didn't matter, traditional craftsmanship didn't matter. The specification was asking designers to throw out everything they knew about gunsmithing, to create something that would be rejected by any peacetime inspector, something crude and ugly and cheap, but something that worked, and something that could be produced right now. Major Reginald Shepard heard about this requirement. Shepard was an army officer with engineering background. Harold Turpin worked at Royal Small Arms Factory Enfield, not as a traditional gunsmith, as a production engineer. Neither man had spent decades learning traditional gunsmithing. Neither man was constrained by traditions about how military weapons should be designed. They approached the problem like engineers solving an equation. What does this weapon absolutely need to do? How can we make it do that using the simplest possible methods? How can we eliminate every unnecessary component, every unnecessary manufacturing step? The design they came up with looked like an insult to traditional gunsmithing. The barrel was a tube, just a rifle tube, no fancy contours, no precision external machining, just a tube. The receiver wasn't machined from solid steel. It was stamped from sheet metal, stamped like you'd stamp out tin cans, then welded together. The welds were visible. The metal was rough, cheap mass production using the fastest possible methods. The bolt was a chunk of metal with a firing pin. That was it. No complexity, no refinement. Just a heavy piece of metal that could chamber around and strike the primer. The magazine housing was welded to the side instead of underneath. This made the weapon look deformed, made it awkward, but it massively simplified manufacturing. Bottom-mounted magazines required complex machining. Side mounting just required welding a tube to the side. Fast, cheap, ugly. The stock wasn't wood. Wood required carpentry and time. The stock was wire, just wire bent into a shape you could put against your shoulder. It folded to reduce bulk, was skeletal and uncomfortable and looked terrible, but it saved materials, saved time. The entire weapon contained 47 parts, 47. A Thompson had over 100, an MP40 had 70. Fewer parts meant faster assembly, fewer things that could break, simpler maintenance. The Sten could be completely field stripped without any tools, just your hands. Take it apart, clean it, reassemble, all in under a minute. Manufacturing required basic metalworking equipment available in thousands of facilities, a stamping press, welding equipment. That was it. No precision lathes, no skilled fitting. A worker with minimal training could stamp out Sten parts, could weld them together. The cost was obscene, £2 sterling per unit, 1/10 the cost of a Thompson. The manufacturing time was 5 man-hours. 5 versus 70 for a Thompson. A single factory making Stens could produce weapons 14 times faster than a factory making Thompsons, and those Stens would cost 1/10 as much. For a nation facing possible extinction, these numbers were the difference between survival and defeat, the difference between having weapons and having nothing. Testing the prototype revealed exactly what you'd expect. The weapon was crude. Accuracy beyond 50 meters was poor. The trigger was absurdly sensitive. Barely touch it and the weapon would fire. Drop it and it might empty the entire magazine. This was dangerous, but fixing it would have increased cost and manufacturing time, so the sensitive trigger stayed. The side-mounted magazine was a disaster for handling. It caught on everything, door frames, equipment. Would get bumped and cause feeding failures. The weapon was ungainly, awkward. the wire stock dug into your shoulder, was loud, unpleasant to shoot, but it worked. The blowback operation was simple and reliable. The open bolt design meant the weapon couldn't cook off. The loose tolerances actually helped with reliability. Dirt that would jam a precision weapon just fell through the gaps. Sand that would lock up tight tolerance weapons didn't affect the Sten. Field stripping required zero tools. Anyone could maintain it. Damaged parts could be replaced by anyone with basic metalworking skills. Production started in 1941. That first year, Britain manufactured 100,000 Stens. The next year, production hit 500,000. By 1943, production exceeded 1 million annually. Peak monthly production was over 100,000 units. Total wartime production exceeded 4 million units, making it one of the most produced submachine guns in history. This production didn't crowd out other weapons. The Sten could be made anywhere there was basic metalworking capability. Small workshops, bicycle factories, automotive suppliers, even toy manufacturers, all of them could produce Sten parts. The cost savings were staggering. 4 million Stens at £2 each meant £8 million total. Britain spent more than that on individual warships. For £8 million, Britain armed its entire infantry with close-quarters automatic weapons. When British soldiers first received Stens, the reaction was disgust. These were men carrying Lee Enfield rifles, beautiful weapons, or Thompsons, which were even better. The Sten looked like something from a scrapyard. Soldiers called it the stench gun, the plumber's nightmare, the Woolworth special. The nicknames were bitter, contemptuous. British soldiers felt insulted. Officers particularly hated carrying them. An officer with a Sten looked poor, looked desperate. Many officers flatly refused to carry them, kept their revolvers, kept their dignity. Then combat happened. North Africa. Desert fighting, where sand got into everything, where weapons that required precision tolerances seized up. The Sten's crude construction became advantage. The loose tolerances let sand fall through. British troops in Tunisia found that Stens kept firing after being dragged through sand that would disable MP40s or Thompsons. Italy. Mountain fighting, where weapons got dropped on rocks, got covered in mud, got frozen overnight and baked during the day. The Sten kept working. The simple design meant there wasn't much to break. Bent the receiver. It still fired. Damaged the stock. Who cared? It was just wire. Urban combat. Fighting through Sicily, through Italian mainland, where every room might contain enemies, where reload speed mattered more than accuracy, where weight mattered because you were carrying it all day. The Sten excelled. Light enough to carry without exhaustion, simple enough to reload in darkness, reliable after being dropped in rubble. British infantry learned to use Stens for what they were good at: close quarters, urban combat, building clearing. They kept their rifles for long-range work. But when fighting got close, when enemies were meters away, the Sten was better than anything else available, better than Thompsons that were heavier, better than rifles that were too long. By 1944, experienced British infantry had accepted the Sten. Not with love. It was still ugly, still had problems, but it worked reliably, worked in conditions that disabled supposedly superior weapons. Officers who'd initially refused to carry them were carrying them in Normandy, because survival mattered more than pride. The German reaction followed a pattern: initial contempt, then grudging respect, then systematic adoption, then trying to copy it. Early in the war, captured Stens were used for propaganda. Look at what the British are reduced to making. German soldiers examining captured Stens laughed at the construction, mocked the visible welds, called them British junk. Then German soldiers started actually using captured Stens, started discovering they worked really well. The 9mm ammunition was identical to MP40 ammunition, made captured Stens immediately useful. The weapons were reliable, easy to maintain. German troops began keeping captured Stens as supplementary weapons. By 1943, German forces on the Eastern Front were systematically using captured Stens. Some German units actually preferred Stens to their own MP40s, found the British weapon more reliable under extreme conditions. This preference was remarkable because German soldiers generally avoided captured weapons due to supply complications. German intelligence reports from 1944 acknowledged what combat troops knew. The Sten was effective. The crude construction actually provided advantages. British engineers had achieved something by prioritizing function over form. Some reports recommended that German submachine gun designs should incorporate these simplification principles. Late in the war, Germany tried copying the Sten. The Gerät Potsdam was essentially a German Sten, crude, simple, designed for rapid mass production. Never produced in significant numbers because Germany collapsed. But the fact that German engineers tried copying a weapon they'd initially mocked said everything about the Sten's success. D-Day, June 6, 1944. British paratroopers dropping into Normandy carried Stens as primary weapons. Light, compact, reliable. A paratrooper had weight limits. Every gram mattered. The Sten was light enough that paratroopers could carry it, plus everything else. Commandos storming beaches preferred Stens for clearing bunkers. High rate of fire at close range, perfect for suppressing defenders. British infantry advancing through bocage country found Stens ideal for hedge-to-hedge fighting. The Norman hedgerows created a landscape where visibility was meters, where ambushes happened at point-blank range. The Sten excelled in these conditions, but the Sten's greatest strategic impact came through its distribution to resistance movements throughout occupied Europe. Britain's Special Operations Executive recognized the Sten was perfect for resistance forces. Simple enough that resistance members with zero training could learn to use it in an afternoon. Cheap enough that Britain could afford to produce them specifically for resistance distribution. Reliable enough to keep working despite terrible storage conditions and irregular maintenance. Starting in 1942, the RAF began systematic drops to resistance groups, not small numbers, massive quantities. The French resistance alone received over 100,000 Stens by D-Day. 100,000 automatic weapons distributed to irregular fighters throughout occupied France. The Polish Home Army received tens of thousands. Norwegian resistance, Danish resistance, Belgian partisans, Dutch underground, Yugoslav partisans, Greek resistance all received Stens. The weapon became the standard arm of resistance movements. For resistance fighters, the Sten was transformative. Before receiving Stens, most were armed with hunting rifles, pistols, armament adequate for assassination but useless for actual combat. The Sten changed everything. Automatic fire meant resistance fighters could actually engage German forces in firefights, could conduct ambushes, attack convoys, fight rather than just sabotage. The weapon's simplicity meant minimal training. The loose tolerances meant it kept working even when buried in gardens or hidden in haystacks for months. The 9mm ammunition could be captured from German forces. Every German soldier killed provided ammunition for continued resistance. Resistance forces learned hit and run tactics, ambush German patrols, rapid fire from close range, escape before reinforcements arrived. The weapon's compact size made it easier to conceal than rifles. Fighters could break down Stens quickly, hide components separately, reassemble when needed. The strategic effect was immense. German occupation forces throughout Europe faced enemies armed with modern automatic weapons, created security requirements that tied down massive numbers of German troops. Every German soldier guarding railways was a soldier not fighting on the Eastern Front. Every soldier protecting factories was a soldier not available for frontline combat. Estimates suggest over 500,000 German troops were tied down in occupation duties. Troops desperately needed elsewhere. The Sten created this effect for £8 million, less than the cost of a few capital ships. For that investment, Britain armed resistance movements throughout an entire continent and forced Germany to deploy hundreds of thousands of troops away from critical fronts. When D-Day came, resistance movements rose up throughout France. Armed with Stens, they attacked German communications, ambushed reinforcements moving toward invasion beaches, cut railway lines, created chaos throughout German rear areas. The coordination was remarkable. British troops landing on beaches were armed with Stens. Paratroopers dropping inland were armed with Stens. Resistance fighters attacking German rear areas were armed with Stens. Same weapon, same ammunition, same tactics, created unified effort that complicated German response to invasion. German defenders in Normandy found themselves facing Stens from multiple directions. British infantry clearing villages, paratroopers securing crossroads, resistance fighters ambushing supply convoys. The ugly weapon that German propaganda had mocked was everywhere, was effective, was killing German soldiers. Post-battle assessments acknowledged what combat had demonstrated. British after-action reports praised the weapon's reliability and suitability for close-quarters combat. German analyses noted the effectiveness of British small unit tactics built around submachine gun employment. 4 million Stens produced between 1941 and 1945. £8 million sterling total investment. That investment armed British forces throughout the war. Armed resistance movements throughout occupied Europe provided capability that wouldn't have existed otherwise. The weapons weren't perfect, but they were available, were affordable, were adequate, and adequate weapons in massive quantities available immediately beat perfect weapons in limited quantities available eventually. Some British soldiers died because they carried Stens instead of better weapons, were killed by accidental discharges, lost firefights because of Sten limitations. These costs were real, but the counterfactual matters more. British soldiers without Stens would have lacked close-quarters firepower, would have been at severe disadvantage in urban combat. Resistance fighters without Stens would have remained largely ineffective. Battles won because British forces had adequate firepower might have been lost waiting for perfect weapons that couldn't be produced in adequate quantities quickly enough. The strategic calculation favoured the Sten despite all its shortcomings. Britain needed specific capability immediately using limited resources. Traditional procurement couldn't provide that capability quickly enough. The Sten could and did. The weapon succeeded, not because it was brilliantly designed in abstract engineering sense, but because it solved a specific problem under specific constraints. That willingness to accept crude solutions when circumstances demanded them was more important than any technical achievement. The recognition that perfect weapons arriving too late were worthless compared to adequate weapons available immediately. The understanding that industrial war required fundamentally different thinking than peacetime procurement. The Sten represented a fundamental philosophical shift. From peacetime assumptions about quality and craftsmanship to wartime priorities of function and availability. From the belief that weapons should be carefully crafted by skilled artisans to recognition that total war required mass production by semi-skilled labor. From the assumption that soldiers deserved the finest weapons to pragmatic acceptance that soldiers needed adequate weapons in sufficient quantity more than perfect weapons in limited numbers. Every design choice reflected these priorities. The stamped receiver instead of machined, the welded construction instead of fitted, the side-mounted magazine, the wire stock. Each choice made the weapon uglier and made it cheaper and faster to produce. The statement was that ugliness was acceptable if it enabled capability that wouldn't otherwise exist. British soldiers understood this calculation even if they never articulated it. The weapon was ugly, but it was theirs. It was available when they needed it. It worked adequately. In situations where traditional procurement would have left them with only rifles, the Sten gave them automatic weapons. Resistance fighters understood even more clearly. The Sten represented tangible British commitment, real weapons in real quantities, weapons they could operate immediately, maintain with basic tools, that kept functioning despite terrible storage. The crudeness was irrelevant. Availability was everything. The lesson extended beyond weapons to fundamental questions about industrial mobilization. Peacetime industry prioritizes quality and refinement. Total war requires different thinking, products adequate for immediate needs. Producible quickly using available resources. The nation willing to embrace crude functionality had enormous advantages. Germany struggled with this throughout the war. German industry produced marvels of engineering, sophisticated, refined, expensive, time-consuming. The MP40 was superior to the Sten in almost every measurable way. Better accuracy, better handling, better appearance, but it required more time and skilled labor. Germany couldn't manufacture MP40s in needed quantities. The sophistication became liability. Britain embraced crude functionality when circumstances demanded it. The Sten wasn't produced because British engineers couldn't design better weapons. It was produced because better weapons couldn't be manufactured in adequate quantities quickly enough. The willingness to accept ugly solutions was strategic advantage. This remained relevant long after 1945. Military procurement in peacetime reverts to traditional thinking, prioritizing capability over cost, assuming future wars will allow time for perfect solutions. The Sten's history suggests different approach, that nations should maintain capacity for crude mass production, should remember that adequate weapons in large quantities often defeat perfect weapons in small numbers. The weapon itself disappeared from service within years of war's end, replaced by more refined designs as peacetime returned. But 4 million Stens had done their critical work. Armed British forces through desperate years, armed resistance movements helped win a war that couldn't have been won without them. The ugly gun that German soldiers initially mocked, that British soldiers initially resented. That looked like it had been assembled in a plumber's workshop. That ugly gun outperformed every reasonable expectation by embracing one fundamental principle. Available immediately beats superior eventually. Adequate in massive quantities beats perfect in limited numbers. Crude functionality producible with existing resources beats sophisticated refinement, requiring resources that don't exist. That was the genius of the Sten. Not the specific engineering, the thinking that produced it, the willingness to abandon peacetime standards when survival demanded it, the recognition that Britain's circumstances required weapons producible with resources Britain actually had, the acceptance that immediate adequacy mattered more than eventual perfection. Klaus Richter in that burned farmhouse in eastern Prussia understood this without consciously thinking about it. The crude weapon in his freezing hands still worked when every sophisticated weapon German industry had produced with such care had failed. The cheap gun outlasted the expensive ones. The quickly made outlasted the carefully crafted. Maybe the British understood something about war that we didn't. They understood that wars aren't won by nations with the best weapons in abstract technical sense. Wars are won by nations that can put adequate weapons into enough hands quickly enough to matter when it matters. The Sten was adequate, it was available, it mattered, and that was the only measure that counted.